Yes, guys. So let's look at this session of permutations and combinations. Now, this question says how many words can be formed such that the words begin with a vowel. Okay. So if I look at my vowels here, I have E, U, A, and I are the vowels. Q, L, and T Y are the consonants. Okay. So the words have to begin with a vowel 3, 4, 5, 6, 7, 8. So the first place can be filled by any of the four vowels E, U, A, I. Okay, any one of these. So four ways, and the remaining seven things in seven places will be 7 factorial. So therefore, your answer becomes 4 into 7 factorial. At this point, clear, guys? Yeah, should be easy. So now I want the words Nainital and such that the letter should end with an N. Okay. So now please understand, when I'm blocking a letter, you divide by those many factorials if we are arranging them. Right? But now here I am blocking my last letter N. If I'm blocking my last letter N, please understand this is treated separately. Now I would be only arranging this part, okay? Now in this part, I see N, A, I, T, and L. Clear? So I repeat, I'm arranging only this part, which means my total number of ways will be 7 factorial. I have 2 N's and I have 2 I's. So 2 A's and 2 I's. So this should be your answer, guys. Am I clear here, guys? Yep. Let's solve this, please. Yeah, I'm not arranging. I'm only arranging the remaining 7, Kadama. Vasant, what is the problem in this? Are we not arranging the remaining 7, Nana? Yeah, only N is fixed. So remaining 7, you have to arrange them, right? This 2 factorial is for A's and I's, Vasant. How many A's do you have, Vasant? Now, please understand, this question should not be misinterpreted like this. The question says how many words are not having this part. Do not end with L and do not end with T. That means they don't want this combination. Okay. If you do not want this combination, then can I say that the total number of words minus those which begin with L and T should be my answer? Clear? So what are my total number of words here? My total number of words are 8 factorial by 2 factorial into 2 factorial into 2 factorial minus, if I'm blocking L and T, what am I arranging here, guys? I am arranging N, A, and I, which means I would get this as 6 factorial by 2 factorial into 2 factorial into 2 factorial. Now this should be your required answer. From two similar ends, there is only one way to pick that kesari, not two ways, Amma. Two same ends, Amma. Yeah, I'm understanding the previous one only. From two identical ends, in how many ways can you pick one end, Amma? Yes, can we solve this question, please? Take 1 minute. Now let's see this, guys. So this question says that how many words can be formed using all the letters of the word Nainital which begin with L and do not end with T. Okay. Which means what? I am looking at all the letters beginning with L. And from here, I'm subtracting all the letters beginning with L and ending with T. 3, 4, 5, 6, and ending with T. Yeah. Because the question says the letters have to begin with L but not end with T. So from all the letters starting with L, I take out all the letters starting with L and ending with T. So all the letters starting with L would be 7 factorial by 2 factorial into 2 factorial into 2 factorial. And from here, I subtract 6 factorial by 2 factorial into 2 factorial into 2 factorial. This becomes your answer. Clear, guys, everyone? Any doubts? Can I proceed from here? Perfect. Yeah, Mahima, Chepamma.
Sir, begin with L fix చేసి లాస్ట్ పొజిషన్ లో టీ కాకుండా మిగిలిన తీసుకుని అలా చేయకూడదా సార్?
అలా కూడా చేయవచ్చమ్మా. దట్స్ నో ప్రాబ్లం ఇన్ దట్. బట్ ఆన్సర్ సేమ్ రావాలి. 540 రావాలి.
ఓకే సార్, అంతే వచ్చింది
నీకు
సార్.
540 వచ్చిందా? అయితే సేమ్ అమ్మా. దెన్ దట్స్ నాట్ ఎ ప్రాబ్లం.
ఎస్ సార్.
యా. Now, whenever I say all the vowels are together or a certain group of items are together, the best part to do is, tie them as a unit or tie them a rope. So what are my vowels here? My vowels are E, U, A, and I. I'm tying them as a rope or I'm considering them as one unit, okay? And this is Q, L, T, Y. So how many units are there now? So you have 1, 2, 3, 4, and 5 units. So please understand, whenever it says all the vowels are together or something, there are two kinds of arrangements. One is an external arrangement, followed by there is something called an internal arrangement. Now, what is an external arrangement? I am seeing externally 1, 2, 3, 4, 5 things are there. In 5 places, that will be 5 factorial. Now, internal arrangement is I get inside the rope. Inside the rope, I see there are 4 different things in 4 different places, and the answer becomes 5 factorial into 4 factorial. Is that point clear by everyone? So kindly remember this. So we tie them a rope. Yep. Can we solve this question, please? Now this question says all the vowels are not together. Now, if all the vowels are not together, I repeat, all the vowels are not together would be total number of arrangements minus the number of cases where vowels are together. Okay. So total number of cases is going to be 8 factorial by 2 factorial into 2 factorial into 2 factorial minus the vowels being together. Now let's understand what is happening with the vowels being together. Now in Nainital, what is happening, or what are my vowels here? The vowels are A, I. Okay. I'm considering them as one unit. Then I have N, T, L. Okay. So this is 1, this is 2, this is 3, this is 4, and this is 5. These are my 5 units. So 5 units in 5 places will be 5 factorial, but remember out of that 2 n's are same. So divided by 2 factorial multiplied with internal arrangement. Internal arrangement, I see 4 letters in 4 places is 4 factorial. Amongst them 2 a's are same and 2 i's are same. This becomes our answer, guys. Is this point clear with everyone? So total number of cases minus all the vowels are together becomes the case where all the vowels are not together. I repeat, when the question says all the vowels are not together, any 3 of them can be same. There are 4 vowels, right? So 3 can be together, or 2 can be together, or none of them are together. Clear? The only thing that I have to remove is all the vowels are together is what we have to remove. Can we tie on a vowel and a consonant? That will also have other cases also, Nana. That's what you're committing a mistake. When you're tying a vowel and a consonant, you are in a way doing that as alternate arrangement. The question is not asking alternate arrangement. This also is possible, Nana. N-A-A-I-N-T-L. ఇంకా ఒక I ఇక్కడ పెట్టుకోవచ్చు. Now, are all the vowels together? No, all the vowels are not together because 3 of them are here and the 4th one is here. అర్థమైందా వసంత్? Great. Alternate positions will come, Nana, don't worry. Yeah, your question, Harsha. See, you asked for it and it came. Yep. Now, in alternate positions, guys, remember, there are 2 cases, okay? I'm explaining both the concepts here. Whenever I'm going with alternate arrangements, now there is a case where the number of vowels and number of consonants are same. If the number of vowels and number of consonants are same, always remember your answer is going to be 2 into x factorial into x factorial. Let's take in this case. I have 4 vowels and I have 4 consonants. Okay. Now, why 2 cases? Because I can start arranging a vowel here. So I can go with VC, 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 and VC. So 4 vowels will arrange themselves in 4 places in 4 factorial ways. And 4 consonants will arrange themselves in 4 places in 4 factorial ways. Or the other way around would be CV, 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 and CV. So these are the 2 cases that we look at when we are having equal number of items. Okay. So for this question, your answer becomes simple: 2 into 4 factorial into 4 factorial, which means 24 square is 576, and 576 into 2 becomes your answer. What is the other model? What if the one group is one more than the other? Okay. If one group is one more than the other, then alternate positions will be x plus 1 factorial into x factorial only. If let's say I have 3 vowels and 4 consonants, so you will have to have only one arrangement. You can see CV, 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 and C. This will be the only arrangement that you will have. If you start with a vowel, you see vowel consonant, C1, C2, vowel consonant, and there is no more vowel. So there has to be a 4th consonant, which will not be alternate arrangements. So only 2 cases with alternate arrangements are possible: if both the groups are of same number, or if one group is one more than the other. Is this point clear, guys? Anything more than this is not possible. If I go ahead with one group, two more than the other, you cannot arrange them in alternate places. Am I clear with this concept of alternate arrangement, guys? Yep. Can we solve this question, please? Yep. Let's see. Now, what is happening here, guys? How many vowels do I have? I have two vowels. How many consonants do I have? Sorry, I have three vowels, I, and A. And how many consonants do I have? I have two consonants. Clear? So how do we arrange them? So three vowels will arrange themselves in three places in three factorial ways. Divided by two i's are same, so divided by 2 factorial. Multiplied with two consonants will arrange themselves in two places in 2 factorial ways. That's it, because the gap is 1 here. So therefore our answer becomes 3 factorial, that is equal to 6 ways. Clear, guys? Now we're moving to the next model called no two vowels are together. Can you take a minute and solve this, please? So what do I mean by equality such that no two vowels are together? Okay. So whenever I say no two vowels are together, the condition is on vowels. The condition is not on consonants. So my question to all of you is, can two consonants be together? Yes, no, yes, no, yes, no. Of course, yes. See, we have four vowels, Nana. So let's say we have V1, V2, V3, and V4. And we have four consonants, C1, C2, C3, and C4. So what is acceptable? One, students generally misinterpret as something like this. Alternate positions, which is definitely there. Okay. Which is definitely there. But please appreciate, even this case is acceptable. Let's say no two vowels are together, kada. Let's say V, CC, VC, VC, and V. Now check, are any two vowels together? No two vowels are together. I have V here, I have V here, I have V here, and I have V here. Right? Or I can have C, V, then again I can have CC, then I can have VC, VC, and V. 1, 2, 3, 4, right? Sorry. Clear, guys? So one more case that I can have here is I can have a V from here, C from here, V from here, C from here, V from here. Then I can have 2C here. Then I can have a V here. So please remember, the condition is on vowels. So let the vowels be separated, but the consonants can be together. So look at this process, guys, everybody. I guess the answer is wrong here. Let us see. The process is quite simple, guys. The process here is simple, that If no two vowels are together is given, arrange the opposite party. Which is the opposite party here? The opposite party is consonants. Now, how many consonants do I have, guys? I have 4 consonants. I will arrange them in 4 places in 4 factorial ways. Clear? Ravali, your answer is all the vowels are not together, which is wrong. All the vowels are not together. 3 vowels can be together. Ikkada no 2 vowels are together is given none. Clear? Now remember, if I'm arranging my consonants, see here, C, 1, 2, 3, and 4. Okay. Please remember, a vowel can be arranged in any of these 4 places. Are you getting the point, guys? That 2 vowels have to be separated by minimum 1 consonant. So how many places are these? These are 5 places. In these 5 places, I have to arrange 4 vowels. So this becomes your answer. 4 factorial into 5p4. I repeat, always arrange the opposite. Clear? Then number of places will always be 1 more than the number of characters of opposite. So 5p4 becomes your answer. Is this point clear? Sorry, it's multiplication here. 4p4 into, sorry, 4 factorial into 5p4. I'm sorry. Thank you, Shravya. If you are given only 2 vowels, no problem, Amma. If you are given only 2 vowels, 4 consonants is 4 factorial. In any of these 5 places, you will arrange 2 vowels. The number of terms to arrange, why not 5c4? Shravya, when you're saying 5c4, you're only selecting them, you're not arranging them. Ardhamainda? 5p4 takes care of arrangement also. C4 is only selection. I'm only selecting 4. So what 5c4 means here is 5c4 is out of these 5 places, you are selecting 4 places. Now you have to continue. In those 4 places, you have to arrange 4 vowels. In how many ways, Amma? 4 factorial ways. Now NCR into R factorial is equal to NPR. Clear, Savya? You're not just selecting 4, you have to arrange them also. Can I proceed, guys? No two vowels are together. This is a question which people confuse with all the vowels are not together or alternate positions. No two vowels are together. So by heart this logic. The answer is wrong here. Ignore that. Yeah, can we solve this, please? Very interesting question. Exactly right, Pawan 213. You are correct. This is not possible at all. Remember, no two boys are together. Wherever the condition is applied, let's say I have two groups called X and Y. If I'm having a condition here, no two X's are together, then you need to understand that X can be equal to Y or X has to be less than Y. X cannot be greater than Y by more than 1. Worst case, you can have X plus 1 and Y. Sorry, X and X. Okay. Comparative. Worst case, you can have 1 more than Y. Okay. So worst case, you can have X is equal to Y plus 1. That will also give you alternate arrangement somewhere. But if X is more than Y, you cannot have no two vowels are together. So therefore, the answer is no such way is possible. Can we solve this, please? Now let's follow it together, guys. No two girls are together. So I first arrange boys. 5 boys in 5 places will be 5 factorial. Clear? Now, in any of the 6 places, I have to arrange the remaining 3 girls. So 6p3 becomes your answer. Is this clear with everyone, guys? No two boys, the answer is 0, Nana. Now, whenever I'm making people arrange in a circular table manner, okay. Now, the only difference between circular and linear is in circular, I do not know which is my starting position, which is my ending position. But in linear, I know that this is my starting and this is my ending. So in circular, we have to first fix up one person. Having fixed one person, only then I can fix the remaining 5. Okay, let's say this is 1, 2, 3, 4, 5, 6. So I'm fixing this, right? So the remaining 5 people arrange themselves in 5 factorial ways. So if you have n people to arrange in a circular manner, circular permutation is it is called, the number of ways is always n minus 1 factorial. Can we solve this, please? Now, whenever you have questions on garlands or necklace, remember your clockwise and anti-clockwise comes into picture. Can you just take a minute and solve this, please? Now, whenever we are talking about garland, please remember, guys, your clockwise and anti-clockwise would remain the same. Okay, no matter if the flowers are distinct. So therefore, if you have to arrange n distinct objects in a garland or in a necklace, the number of permutations are always n minus 1 factorial by 2. Clear, guys? And that's going to be 6 factorial by 2. Always remember this, guys. Be it distinct or be it identical, garland or necklace, the clockwise and anti-clockwise is always the same. So therefore, we are dividing it by 2. Can we solve this, guys? There's a lot of difference between linear and circular, Amma. Divided by 2 because in a garland or a necklace, the clockwise and anti-clockwise directions are same. Therefore, we divided by 2. Yep, let's see this, guys. Now, what is happening here? In a circular fashion, you need to remember that extra spaces are not created. So, in linear manner, what is happening is, suppose I'm arranging in a linear fashion. I'm arranging certain people. So, what is happening? Let's say I'm arranging 1, 2, 3, and 4. So, how many places are created? This end also gets created. This end 1, 2, 3, 4, and 5. Now, let's say if I'm having a circular fashion and I am arranging, let's say 1, 2, 3, and 4. Now tell me how many places are created, guys. This is one place. Okay. This is the second space. This is the third space, and this is the fourth space. Now that is the major difference between arranging in a row and arranging in a circular track. So since no two girls are together, step number 1, we have to arrange boys. Now 7 boys in circular manner. Can I say 6 factorial ways? Yes, no, yes, no, yes, no. Now, if I'm arranging 7 boys, the number of places created will be 7 only here. Okay. If the number of places created will be 7, so in how many ways can we arrange girls in 7 places? 7 girls in 7 places will be 7 factorial. So your answer for this question is 6 factorial into 7 factorial. Clear, guys? It's a necklace. Don't forget that. So let's see here. So I have, let's say, bead 1, bead 2, bead 3, bead 4, bead 5, 6, 7, and 8. So I'm saying that these 3 particular beads are together. No issues. So how many items do I have? I have 1, 2, 3, 4, 5, and 6. So 6 items in a circular manner would be in 5 factorial. And since I'm arranging in a necklace, this becomes 5 factorial by 2. External arrangement. Now these 3 beads can arrange themselves in 3 places. Can I say in 3 factorial ways? So our answer becomes 5 factorial by 2 into 3 factorial. Is this point clear, guys? Quick responses, please. Whenever you are arranging in a necklace or a garland fashion, guys, remember you are counting it twice because clockwise and anti-clockwise will still be the same. Are you getting it 4K3 now? Yeah, let's look at selection of persons now. Okay, now how many ways can I select people? Now, whenever I'm selecting people, please remember selection is always NCR. If I'm selecting and arranging, so NCR into R factorial is equal to NPR. I always use this logic here. I rarely use NPR directly. The logical sense is I first choose, suppose you have, 5 new shirts in your wardrobe. Okay. And you have 3 days of Pongal. In how many ways can you wear the 3 shirts out of 5 on those 3 days of Pongal? So what I would do is I would first go and select my 3 favorite shirts among. Now I have 3 shirts with me. Now 3 shirts in 3 days can be arranged in 3 factorial ways. So my answer becomes 5C3 into 3 factorial, which is nothing but 5P3. right? But why 5C3 into 3 factorial is what I prefer, because that's a more practical approach here. And that's where we all get stuck. So to just understand, where do I apply C, where do I apply P? Okay. Now let's look at this selection of persons. Can we solve this, please? Now remember here, this kind of questions is, in how many ways can 5 members be selected from 6 men and 5 women, such that a particular woman is always present. Let's say I am identifying that person to be, let's say Shravya from the class. That specific Shravya, let's say some Shravya called P Shravya. Now I know this is a particular person in the class. So I am not having any role to choose her. So she is already there, which means I have 10 people left now, and I have to choose the remaining 4. So therefore my answer becomes 10C4. Quick responses, guys. Yes, no, yes, no, yes, no. So when a particular person is what I'm saying, that means that person is already identified. Can we solve this, please? No, exactly right. Particular man is always absent. Let's say Suraj is always absent. So we have identified who is absent. Suraj is always absent. So chuck him. I have 10 people, but I have to choose 5. So therefore my answer becomes 10C5. Perfectly right, guys. Now comes the really two beautiful questions. Can we solve this, please? It's a very lovely question, guys. This and the next one. Yeah, let's see this, guys. Now, this question says that how many ways can 5 members be selected from 6 men and 5 women, such that 2 particular women insist on going together? Let's say those 2 particular women are A and B here. So A says, if B come, only then I will come. Now, what is a possibility? A possibility is I am taking both of them in my team. Okay. If both of them are in my team, that means I have to choose how many more guys? I have to choose 3 from how many people? Out of 11, 2 people are gone. Out of from 9 people, so 3 out of 9 people will be 9C3. This is case 1. Now this is second case. Why so much of tension? Dump both of them. So if I'm not selecting both of them, which means I have to now choose how many people? I have to now choose 5 people from a set of 9 people only. So therefore your answer becomes 9C3 or 9C5. Any doubts, please ask. Nine C5 is when I'm not selecting both of them here. Uday, were you there in the morning class, Amma? Uday. Yep, can we solve, please? Now, two men insist on not going together. This is again a very beautiful condition here. And that are two particular men. So when I'm saying two particular men, let's see what is happening here. Suppose A says A and B have a fight here. A says if B will, B says if A will come, I will not come. A says if B will come, I will not come. So let's say I'm inviting my friends for birthday party. So I know any one of them will come. So out of 9, can I say I have to choose 4? Yes, no, yes, no, yes, no. Why 10C4? Yeah, 9C4 kadamma. Because two particular men are identified. So out of 11, 2 men are identified. So remaining are 9 kada. Out of 9, I'm selecting 4, or out of 9, I'm selecting 4. Now my problem is, if I invite A, B will feel bad because B is my good friend. If I invite B, A will feel bad because A is, both of them are my good friends. So therefore, what I'll do is, I'll tell bro, I don't want this headache. If I don't want this headache, then what do I want? So either this happens, or this happens, or this happens. So whenever I'm going independently, I can choose any one of them independently. Clear? So whenever I go with independent operations, I go with addition. Clear, guys? Exactly right. There's one more way of doing it. The other way of doing it is, the only other condition left is both of them are together. So total number of ways minus both of them together will be the case when both of them are not together. 1A0, I am identifying B కదమ్మా. B లేదు మన గ్రూప్ లో. అయితే 11 నుంచి ఇద్దరు వెళ్ళిపోయారు కదమ్మా. You are correct. B is not there in the group. But have you identified B? Yes, you have identified B kada. Clear, guys? Because A is already selected, yaar Pawan. One member is already selected, mama. అందుకే 4. And one number is not selected. అందుకే 9. Committee formations. Can we solve this, please? Let's solve this question. Interesting models, guys. We'll just keep on moving easily now. Yes, can we solve this question now, please? Yeah, so it says very simple question, guys. I have 9 men and 8 women. I want a committee of 7 members without any conditions. So that becomes 17C7 without any conditions. So all of you are correct. That's perfectly fine. Let's go ahead on this. Yeah, can we solve this, please? There's a small trap there, so be a little careful. So I want exactly 6 women here. So if I want exactly 6 women, now please remember, whenever I'm saying exactly 6 women, which means I have to take care of the remaining part. If women are exactly 6 and I want a committee of 7, that means the number of men has to be 1. Clear, guys? So therefore, if the number of women are 6, I would go with 8C6 as the number of women multiplied with, not a plus Ganesh, it's into. Because if you have, let's say, woman 1, or let's say all the set of women here, 6 women are here, okay? Now either you can go with M1, or you can go with M2, or you can go with M3, or you can go with M4, and so on, so on, so on. Clear? So therefore, into 9C1 becomes your answer. So 8C6 into 9C1 is your answer. Sometimes students commit a mistake by writing 8C6 into 11, sorry, yeah, 11C1, which is wrong. This is always wrong. Because the remaining one person has to be a man only. Because the word is used as exactly 6 women. If it's exactly 6 women, then there has to be one man. Can we solve this, please? So 9 men and 8 women. In how many ways there is at least one woman here? Now understand this, guys. If you want me to make a complete chart, let's say men and women, so I can have 0 men and, or let's say I can have 7 men and 0 women. I can have 6 men and 1 woman. 5, 2, 4, 3, 3, 4, 2, 5, 1, 6, 7, and 0. Now, individually, if you want to do them, this is nothing but 9C7 into 8C0. Okay, this part. Now, this part is nothing but 9C6 into 8C1. Clear? Now, this part is 9C5 into 8C2, and so on, so on, so on. When you add all of these, okay, this is what gives you nothing but 17C7. Now, the question is saying that at least one woman. When I go with at least one woman, the question says minimum one woman. If minimum is one woman, that means maximum is as per the question. Okay. So which means I can go with all these cases is what I'm considering it to be. Is it clear, guys? So one beautiful way of going with at least one condition is, whenever the question says at least one, you can always go ahead with total minus none will give you at least one. So total cases is 17C7, and then from there I'm taking out a case where there is no woman, which means there are only men in the gang. So 17C7 minus 9C7 becomes your required answer. Why 16C6, Jafar? You fix one woman. Which woman? We do not know, Kada. That's the problem with 16C6. Clear, guys? So when we are arranging people, we use permutations. When we are just selecting people, we use combinations here. Here we are just selecting people, we are not arranging them. If you want to understand, I might say that let's take the previous question. And here I would say that you have to make a committee and make them sit in a row. Clear? Make them sit in a row. Even then, the best possible condition here would be, what am I doing? I am taking 8C6 into 9C1. Okay? 8C6 into 9C1 is what I've selected 7 people and I have to arrange them in 7 places, that is into 7 factorial. See guys, I'm again and again telling you, if you're confused between C and P, forget P. I only use C. And I need to know your roll number first, random name, random person. What are they trying to indicate, bro? If you're some random person, you should be out of the class. I want only SRKR roll number students. Who said doesn't take numbers? Everybody's entering roll numbers, Amma. What is your roll number? Richie, name change cheskunta. Everybody has their roll numbers. Now, at most one woman, remember, whenever I'm saying at most, that means it's maximum. At most is always maximum and at least is always minimum. Right, so I'm saying at most one woman, which means I can have 0 women or I can have 1 woman. If I have 0 women, the number of men will be 7. If I have 1 woman, the number of men will be 6. So 0 women and 7 men. So this becomes 9C7 plus I can have 7 men, no? So 7C7. Clear? Or I will have 4C1 into, okay, committee of 5 members. My bad. I have the hangover of the previous question. Committee of 5 members, right? So if I need a committee of 5 members, that means I'm talking about 5 men and here 1 woman and 4 men. Okay. So this will be 7C5 or 4C1 into 7C4. This becomes your answer. At most 1 woman. So you'll have to look at maximum one woman in the group. Am I clear, guys? Random person, this is example is for you. Yeah, let's see this, guys. Now, please understand, suppose you and I are shaking hand. Is it considered as one shake hand or 2 shake hands? Only 1 shake hand, right? Just 1 second, guys. Yeah, when A and B are shaking a hand, it's considered as only one shake hand, right? If it's considered as only one shake hand, clear? Then it's clearly a case of combination. So out of 15, see here, if I'm picking A and B, and it's considered only one, that means I'm selecting two people. So how many such pairs will I select? Because a shake hand is a combination of two people's combination. Clear? So how many such people am I picking up is what I'm looking at, and therefore the answer becomes 15C2. Is this clear? Quick responses, please. Now, what happens when we are giving friendship bands or greeting cards? Now, let's see the same thing here. If A and B exchange the friendship bands, how many friendship bands are exchanged here? One or two? Now, it is like A is giving to B and B is giving to A, which means it is nothing but an arrangement concept. In the previous one, A is giving to B and B is giving to A is one and the same. Right. So just because it is two different things, then I'm going with arrangement. So I'm going with 20P2 becomes your answer. 20P2 guys, I'm sorry. Yep. Can we answer this question, please? Yep. In how many ways can a person invite at least one of the 8 friends in his party? Now, at least one. So, at least one in one case, you can say that is total minus none. Now, let's understand, guys. If I'm inviting no friend in my party, that is done in 8C0 ways, that is also considered as one way. Okay. If I'm inviting one friend in my party, that is considered as 8C1. If I'm inviting two friends in my party, that is considered as 8C2. If I'm inviting three friends in my party, that is 8C3, and so on, so on, so on. N friends in my party will be NCN. So always remember, guys, NC0 plus NC1 plus NC2, and so on, so on, so on. NCN is always the formula is 2 to the power n. So in how many ways can I invite any number of friends in the party? Any number includes 0 also. So any number of friends in the party is always 2 to the power 8. Now the question says at least one. So from the total number of ways, I am taking out the number of ways in which I can invite no friend to the party. Now 8C0 is always 1. So therefore the answer becomes 2 to the power 8 minus 1 should be your answer. So instead of calculating all these things individually, you can directly go ahead and calculate this. Am I clear, guys? So there are 5 reasoning books, 4 quant books, and 3 English books in a shelf. Okay, in how many ways can a person select at least one book on each subject? At least one book, not exactly one book. Okay, now I'm going back to that. So I have to pick at least one book of reasoning and at least one book of quant and at least one book of English. Clear? So if I have 5 reasoning books, 2 to the power 5 will involve, what will it involve, guys? The total number of ways of selecting any number of reasoning books. I don't want any number of reasoning books. I want at least one reasoning book. So can I say 2 to the power 5 minus 1? Now, 2 to the power 4 will be the number of ways of picking up any number of quant books. I don't want to select any number. I want to select at least one. That's 2 to the power 4 into 1. And this becomes 2 to the power cube into 1. So this becomes our answer, guys. 2 to the power 5 minus 1 into 2 to the power 4 minus 1 into 2 cube minus 1. Any doubts here? It is as good as inviting. I have 3 different groups of friends. I just explained Shravya in the previous question. Were you there, Shravya? Out of 5, I am picking 0 quant book. Out of 5, I am picking 1 quant book. Yeah, exactly. You missed that. This amount. This is total number of ways, Kadamba. So this becomes 2 to the power 5 amma. Clear? No issues amma. NC0 plus NC1 plus NC2 and so on, so on, so on. Till NC5 is always 2 to the power 5. Now the question is the 2 to the power n, sorry. Now the question is asking you at least one. I think the question is asking you this, Kadamba. So therefore this value would be 2 to the power n minus selecting 0 option. Selecting 0 option is always 1. ఇప్పుడు అర్థమైందా? Great. It's okay, man. Don't worry. I understand those issues, Amma. Yep. Let's solve this, please. Can you solve this? Now, how do things change from identical options? Now, whenever I say identical, okay. Suppose I tell you that in your library, there are 6 brand new books. Okay. Or let's say 3. Let's understand the difference between identical and distinct. Suppose I'm saying there is a quant 1 book, there is a quant 2 book, and there's a quant 3 book. Okay. Now I'm asking you, and in the other case, I'm saying there is quant 1, quant 1, quant 1, 3 brand new books of same publisher. Tell me in how many ways, see, the number of ways of picking 0 books in both the cases is same. This is 3C0, that is one way, and this is also one way. Now tell me in how many ways can you pick exactly one book? Distinct and identical. Your answer should be something, comma, something. Now, exactly one book here becomes 3C1. That is, it's either Quant 1 or Quant 2 or Quant 3. Three different authors. Ikkada entama, all the three of them are same kada. So can I say I'll just pick the book and I'll come back because I know that those are brand new books. Now, in how many ways will you pick exactly two books, guys? Exactly two అయితే 3C2 ఉంటుంది. Quant 1, Quant 2 combination, Quant 1, Quant 3 combination, and Quant 2 and Quant 3 combination. But here, again, one case, nothing else. Any two out of the three you pick and you come back. Are you getting it, guys? So, number of ways of picking up 0 items out of n identical items is 1. Number of ways of picking 1 items out of n identical item is also 1. 2 items is also 1. Even n items will be equal to 1. So, ikkada number of ways of picking any number of items is 2 to the power n kada. In identical items, number of ways of picking any number of items is always n plus 1. Is this point clear? And when I talk about at least 1 is 2 to the power n minus 1. And here if I talk about at least 1, I have to just remove one case, that will be n case. Is this point clear? Can I get the answer for question number 50, please? So what are the total number of ways? At least one book. It did not say at least one book of each subject. So out of 5 identical reasoning books, the total number of ways of picking any number is 6. And out of 4 quant books, the total number of ways of picking any number of books is 5. And out of 3 identical, picking any number of English books is 4. This is my total number of ways. And the question says at least one book. So from here, I am excluding a route where one is, or where I'm selecting no book. Any doubts here? See, if you have a doubt, guys, let's start understanding this. There's a possibility I might pick 0 reasoning books. Along with 0 reasoning books, I can have 0 quant books, or I can have 1 quant book, or I can have 2 quant books, or I can have 3 quant books, or I can have 4 quant books. So 0, 1, 2, 3, 4, 5. Ivi how many ways lo avutadi? 6. Idi how many ways lo avutundi? 5. Multiplication. Again, I can have 0, or 1, or 2, or 3. This is in how many ways? Into 4 ways. Clear? Minus, there will be only one way in which you have not picked any book, that is 0, 0, 0. So 6 into 5 into 4 minus 1. Now you see, you want to pick at least one book of reasoning. So at least one book on each subject అయితే ఎంత అవుతుందమ్మా? 5 ways in which you can pick reasoning books, 4 ways in which you can pick quant books, and 3 ways in which you can pick English book, because at least one on each subject. And the answer here becomes 60. Now these are the concepts of grouping here, okay? 12C1 is exactly one book 543. The question saying at least one book amount. Yep. So this is gonna be, now grouping has two ways of doing it here. Okay. So this is going to be 12C3 into, I'm left with 9C4 into 5C5. Clear? Or in short, grouping means if you simplify this, you get 12 factorial by 3 factorial into 4 factorial into 5 factorial. Now, grouping has two things. If the groups are distinct, here I can identify my groups. There's a group of 3 people, there's a group of 4 people, there's a group of 5 people. So these are my distinct groups. Okay. Now, what if the groups are identical? Now, in this case, so 12 people, in each group, there are only 4 people only. Now, when our groups are identical, the process in a way remains the same only. This is 12C4 into 8C4 into 4C4. Since three groups are same, divided by 3 factorial. Or in short, this becomes 12 factorial by 4 factorial into 4 factorial into 4 factorial into 3 factorial. So if I can identify my groups, then you need not divide the denominator. But if you're unable to identify the groups, if the groups are identical, then denominator won't come in picture. Clear, guys? Grouping concept. Now, let's try to understand what should be considered. There's always a confusion between 5 to the power 4 or 4 to the power 5. So I always say this is a concept of n to the power r. Okay. Now, what comes in r? I remember r as restricted quantity. What do I mean by restricted quantity? Now, tell me, guys, can a student get more than one prize? Of course, yes. That means students is not restricted. Let's look at the other way around. Can one prize be given to more than one student? No. Since I cannot give more than one prize to one student, now prize is the restricted quantity, which means this represents R. Clear? So therefore your answer becomes 4 to the power 5. I repeat, guys, so it's similar to the first prize can be given to any of the 4 students, right? So it's either A can get it, or B can get it, or C can get it, or D can get it. The second prize can go to A or B or C or D. The third prize can go to A or B or C or D. Are you able to understand, guys? 4 into 4 into third prize into fourth prize into fifth prize. Got the logic now, guys? 4 to the power 5. Great. Last 7 questions for the day. Can you please solve this? Let's solve this, guys. Now, what does this question talk about here? There are 20 points on a plane and 5 of them are collinear. Right? So, first of all, a line is a combination of any 2 points. But we need to understand that from those 5 collinear points, I cannot draw any line except one line. Is this point clear, guys? Any doubts? Because if 5 points are collinear, Amma, this one line has to be counted, kada? See, when you're saying 15C2, you're eliminating the possibility of these 5 points with other points here. The other are non-collinear, kada? Pavan and Mahima. If this will be counted, no? Are you getting it, Pavan and Mahima? So if you're writing 15, in a way you're eliminating these possibilities. So B toti kuda avutai. With C also you will have lines. So by saying 15, you're eliminating all those possibilities. Clear? So therefore, first you make 20. See what is happening here. If you want to understand this concept very well, those 5 points only here, A, B, C, D, E, among themselves, if I write 5C2, what is 5C2 here? Normally ain't out of them. A, B, C, D, E, if they are not collinear, these are the lines that we will have, okay? A, then you'll have BC, then you'll have BD, then you'll have BE, CD, CE, and D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now, when they are on a straight line, Amma, let's say I have A here, B here, C here, D here, and EE here. Okay. Now look at AE. So if I'm considering AE, can I say AB is included in that? AB is already included. AEలో AC కూడా included ఉంది. AEలో AD కూడా included ఉంది. AEలో BC is included. BD is included. So everything is included in a straight line. So when you're subtracting 5C2, you're taking out all the 10 cases. Now what are you adding? This one point that you're adding is A plus E, the master line. This is why it's plus 1. Clear? But when you're saying 15C2, now please remember, after E, can I say AF is also a line? AG will also be a line. AH will also be a line. So you are ignoring all these lines. If you are writing 15C2. Again, the same concept, guys. The triangle is a combination of any 3 points. So 20C3 minus 5C3. You can't form a triangle when you have collinear points. When you have collinear points, you can only make a straight line. Now, number of diagonals. Okay. Now, how is the formula derived? First, I calculate all the lines that can be made with the help of those 8 lines here. Suppose I am talking about a rectangle amma. Okay. So what are my 4 points? A, B, C, D. Okay. So if I look at it, AB is a point, AC is a point, AD is a line. Similarly, BC is a line, BD is a line, and CD is a line. Okay. Now tell me here, what are my diagonals of a rectangle? My diagonals are only AC and BD. Arthamaina? So what is AB? AB is one of the side of the rectangle. What is AD? AD is also one of the sides of the rectangle. What is BC? BC is also one of the sides of the rectangle. And what is CD? CD is also one of the sides of the rectangle. So what did I do? From 4 points, I am counting all the possible combination of lines that I can draw. That's 4C2. Minus, I am eliminating all the number of sides. So 4C2 minus 4 becomes your answer. Is this clear? So the number of diagonals of any polygon need not be regular. Of any polygon is always nc2 minus n, and if you simplify, this becomes n into n minus 3 by 2. Can we solve this question, please? Last model called derangement. Yep. So there are 5 letters and 5 corresponding envelopes. Each envelope can hold only one letter. In how many ways can the letters be placed in envelopes so that they can get into any envelope? So which means in a way I have 5 places. In these 5 places, I have to arrange 5 letters, and therefore the total number of ways becomes 5 factorial, not 5 factorial into 5 factorial power. In any of these envelopes somewhere. So either letter A or B or C or D or E can go. If A is going here, then B, C, D or E can go here, and so on and so on and so on. Yeah, you can do the same thing, Nana. You'll still get 5 into 4 into 3 into 2 into 1, Nana. But the number of ways will be same. You're double counting.
Sir,
Yeah.
actually, if we start from the first envelope, we got 5 factorials. But why can't we start from the second envelope?
You can do
Second
from
or
any
third?
envelope, Nana. The number of cases you will get is 120 only. అర్థమైందా? నువ్వు అన్ని సేమే రాసుకుంటావు కదా.
But if it is starting from the first envelope, remaining 4 envelope misses the chance of getting one number now.
No, you are counting everything కదమ్మా. ఫస్ట్ లో ఏ వెళ్తుంది, సెకండ్ లో బి వెళ్తుంది, థర్డ్ లో సి వెళ్తుంది, ఫోర్త్ లో డి వెళ్తుంది, ఫిఫ్త్ లో ఈ వెళ్తుంది. ఓకేనా? నా ఫస్ట్ లో ఏ ఉంది, బి ఉంది, సి ఉంది, ఇది ఈడి ఉంది. ఇలాగ నువ్వు 120 రాసుకుంటే యు ఆర్ అరేంజింగ్ ఎవ్రీథింగ్. నో, you will see that every letter is going to every envelope. That is arrangement kadamma.
Yes. Okay.
In how many ways can you place the letters such that it is getting into corresponding envelopes? That means if 1 has to go to A, 2 has to go to B, 3 has to go to C, 4 has to go to D, and 5 has to go to E. And there is only one way of it. And the remaining 119 ways, some of the other envelope is going wrong. In how many ways can 4 letters get into the right envelope? Exactly 4. Now remember, if you are saying exactly 4, it has to be 4 in the correct envelopes and 1 in wrong envelope. That is not possible at all. Please remember, if A is going to 1 and B is going to 2 and C is going to 3 and D is going to 4. Suppose these are my 4 correct envelopes. Where is E going? He has to go to 5. Then this also becomes the correct envelope kadamma. And when you're saying exactly 4, that means 4 has to be correct and 1 has to be wrong. That is not possible at all. So therefore, the number of A's is equal to 0. Is this point clear, guys? Now comes is the derangement concept, Nana. It says that there are exactly 5 letters in 5 envelopes. Each envelope can hold only 1 letter. In how many ways exactly 3 of them are going to the corresponding envelope? So remember, whenever I'm saying exactly 3 are going to corrects, I have to ensure that the remaining 2 are going to incorrect, each of them. Now, remaining 2 going to incorrect will always be termed as a concept of dearrangement. The simple formula, no, don't worry. So, dearrangement of n objects is always n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial, so on 1 by n factorial. Is this point clear, guys? Dearrangement of 2 items. Dearrangement means 2 letters are not going into corresponding envelopes. Is this point clear? If yes, please note it down and type a Y on the chat box. Right. Now, how do we solve these kind of questions? It says the remaining 2 need not be, or the remaining 2 definitely should not be in the right envelopes. So first things first, which 3 out of 5 will be 5C3 into 2 should not be in correct kadama, derangement of 2 articles. So what is derangement of 2 articles? That is 2 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial. Clear, guys? And that's going to be how much, guys? The denominator is going to be 2 factorial. This is going to be 2 factorial minus 2 factorial plus 1 into 2 factorial. This gets cancelled. This gets cancelled. So there's only one way of the remaining 2 not to get into corrects. So therefore, the answer here becomes pi C3 into 1, which is going to be 10 ways. Yes, no, yes, no, yes, no. Any doubts, please ask. It is like this, guys. Suppose 1, 2, 3, 4, 5, okay? A, B, and C are going to corresponding envelope, but D is going to 4 and E is going to 5. These two are not in the correct end zones. Similarly, I can say that A, B, and D are going here, but E is going here and C is going here. Then I go with clear. Then I can go with A, B, C is done. A, B, D is done. Then I can go with A, B, and E here. So C is coming here and D is coming here. So if you observe, in each of the cases, what is happening? This is a 5C3 pair, one of the 5C3 pairs. Okay. Second pair among 5C3 pairs. Third pair among 5C3 pairs. Alaga manki 10 cases vastayama. 5C3 kada. ABC, ABD, ABE. Then I can go with ACD and ACE. Alaga chase 10 cases vastayama. Now in each case, the number of ways of not arranging them properly is 1. Are you getting it now? So 5C3 into 1 becomes your answer. Last question of the day. Why will there be only one arrangement, Nana? Yeah, you're right, you're right. Only one will be proper and rest all will be improper. Either derangement of 3 or derangement of 4 or derangement of 5 and so on, so on, so on. Yeah, but n minus 1 factorial are all derangements. Now, ikkada exactly 3 cheppedu. See, if you have 5 envelopes, 5 factorial is total cases, okay? All 5 corrects is how many cases, Nana? Only one case. Now, what is 119 cases? 119 cases will be exactly 3 incorrects and 2 incorrect. Exactly 2 corrects and 1 incorrect. Exactly 1 correct and 4 incorrects. And exactly 0 corrects and 5 incorrects. You add all of them 449. This sum up will be 190. So derangement of 3 gave me 5C3 into D of 2 kadam. Derangement of 2 will give me 5C2 into derangement of 1. Similarly, derangement of 4 will be 5C1 into derangement of 4. Sorry, this is 2 and 3. Clear? And this will be derangement of 5. Now, this question is asking you this case. Exactly 1 is in the right envelope. So, remaining 4 have to be in wrong envelopes. The formula is 4 into 1 minus 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial and plus 1 by 4 factorial. So, if you take the LCM called 4 factorial, this goes off. This also goes off. So, this is 3 into 4 minus 4 plus 1. So 9 ways in which the remaining 4 can go in wrong envelopes, and 5C1 is 5 such combinations. Therefore, the total number of ways becomes 45. Is this point clear, guys? So this completes your permutations and combinations. We will be dealing with probability on Saturday's class. Clear, guys? So that's it for myself today. Take care. Exactly 2 minutes before the class. See you guys on Saturday.